Hi, and welcome to 4.3 Unit Conversion. In this lesson, students will be able to convert between units by multiplying by a conversion factor. So when converting between units, it's helpful to get an idea of what the units look like. So we have the United States customary system with all the familiar players: inches, foot, yard, mile, acre, ounce, pint, quart, gallon. Which are fine, I guess, but I personally like the International System of Units better, or the SI units, aka the metric system, whose base units are the meter, gram, candela, mole, amp, and the Kelvin. Actually, the base unit is a kilogram when doing like physics work and stuff like that. You want to make sure you're plugging in kilograms, but we're going to cover the different prefixes that you get to use for the metric system. You get to use these nice prefixes, makes things easy to work with. But we're going to do those types of conversions in the next lesson. For now, I want to focus on something that is near and dear to my heart: the dimensional analysis method of converting units, multiplying by a conversion factor. So let's say you want to convert 15 centimeters into inches. The first thing you want to ask yourself is, where can I Google that? No, don't Google it. All right, you can do it without Google. I know you can do it with Google, but it's good to know how to do this process, because this will help you in like chemistry and stuff like that, where you're just not going to Google everything. I don't know. Maybe in the future world, maybe Google's going to do everything for you, but it's good to know how to do in the meantime. So the first question you ask yourself is, how many centimeters are in an inch? And if you don't have access to the internet, you can look in your reference table. And then we see that 1 inch is equal to 2.54 centimeters. Okay, so that's going to be effectively our conversion factor. But if you don't do the dimensional analysis thing, you could try to like figure it out in your head. Do we like multiply by 2.54? Or do we do 15 divided by 2.54? Or wait, can I do 2.54 divided by 15? So you don't want to have to guess, is the point. Like if you do this process, dimensional analysis, you're not going to have to guess. You're always going to know if you're doing it right if you do the process. So I'm teaching you a process that you can apply to harder situations later. I know it's probably easy to even just Google this, or maybe you do already know if you should multiply or divide and how to do that. But the thing I'm teaching you is the process, because again, you can apply it to harder things later. So here's the process, and I made it like a rhyme to help remember it, I guess, or just make it like less mathy. I don't know. Just write the number down with its units, please. Okay, so 15 centimeters is what we want to convert, right? We're doing 15 centimeters into inches. So writing the number down with its units, please. Then you multiply by some parentheses. Same process every single time. Put a line in the middle. Don't make it a distraction, because we're about to make a really cool fraction. Write the units you just wrote on the opposite side. So these centimeters are in the numerator. I'm going to write them in the denominator, right? The units you just wrote on the opposite side, so that they cancel out, leaving you with pride. A centimeter divided by a centimeter cancels out. It's like basically equal to 1, and 15 times 1 is just 15. So the units cancel out if they're on the opposite side. Write the unit you want in the only blank space. Okay, we want to go into inches. So the only blank space is, boom, like that. So by writing the units in first and ensuring that they're going to cancel out, you don't have to guess, where do I put the numbers? These units in their placement are going to tell you where to put the numbers. Now you're ready for some numbers to take their place. How many of one thing equals the other? If you lose your reference table, I'll give you another, and actually it's posted on Schoology. So how many of one thing equals the other? 1 inch is equal to 2.54 centimeters. So again, the units tell you where to put those numbers. Okay, I see 1 inch and 2.54 centimeters. You're matching up. You're not guessing. Do I multiply? Do I divide? All that stuff. Multiply the numerator, then the denominator. Simplifying fractions makes me feel phenomenator. Do you remember how to multiply two fractions together? You just do the numerator first. So 15 times 1 is 15. And then the denominator, 1 times 2.54 is 2.54. And then we simplify that by doing 15 divided by 2.54, which is equal to about 5.9, 5.9055. Cancel out those units, and now you're done. Dimensional analysis makes converting fun. So which units can I cancel out? Well, I see a centimeter on top and the bottom, so I could cancel out. And what are we left with? Only inches. So our answer is in inches. And that's how you do it, folks. You're just multiplying by a fraction. You're multiplying by a conversion factor. And by carefully putting the units where they're supposed to be first, that tells you where to put the numbers. So to answer the question from before, we ended up doing 15 divided by 2.54. But this leaves no question in our mind that we did it correctly because we're analyzing the dimensions, we're analyzing the units and making sure that they cancel out the way they should. So it's a really helpful process because if you have like things like going into moles or the next question, it's going to help you if you're just really good at doing this process. Then it becomes a no-brainer. So let's see what this looks like. It says an American car company has designed a new high fuel efficiency vehicle that is rated at 55 miles per gallon. The company plans to export the car to Europe and must advertise the fuel efficiency in SI units. What is the fuel usage rate in kilometers per liter? So we're going from miles per gallon to kilometers per liter, and they tell you the conversion factor for liters and gallons and kilometers and miles. So do we multiply by those numbers? Do we divide? Do we type it into Google? Let's do the conversion factor here. And we have our rhyme on the top in case you want to do that. But really, it's just write the number down, miles, and then I'm going to write per gallon, kind of like this. You could do like this, per gallon, right? But what is that? That's just a fraction. And when we're doing unit conversion, we want to put things in the numerator and the denominator so that we can easily see where they cancel out. So this is basically like 55 miles per 1 gallon if you wanted to write the number down. But you don't have to. Okay, you could just write it like that. Then we multiply by some parentheses. Put a line in the middle. All right, which one do you want to convert first? I see the liter and the gallon thing first. So let's get the gallon. Let's get rid of these gallons. All right, so write the unit that you wrote on the opposite side. So I see gallons on the bottom here. I'm going to put gallons in the numerator so that a gallon divided by a gallon, they're going to cancel out. All right, and what are we going into? We're going out of gallons and into liters. So we put the liter here. And now we don't have to guess as to where to put the numbers. The units, the placement of the units tell us where to put the numbers. So I see that 1 liter is equal to 0.264 gallons. So I know right away I'm going to have to do 55 times 0.264. And then we could do that, and then we'd have an answer in miles per liter, and then you'd convert miles into kilometers. And that's fine. You could definitely do it that way. But one of the added benefits of being comfortable with this process is you could do multiple conversions in one line. Check this out. So we have the gallons are canceled. We want to now change miles into kilometers. Okay, so the miles are on the top here. we want to cancel, we want the miles to cancel out. So let's put them on the bottom. And we want to go into kilometers. So again, it's very important. Put the units in first, then look at your conversion factor, and then plug in the numbers. Everybody's so excited for the numbers. It's all about canceling out the units. Write the units down first. 1 kilometer is 0.621 miles. If you want, before you do your math, you could cancel out the units first. That's the most exciting part, though. I'm going to do that last. So I'm going to like do the whole thing. I'll write it out if you want. So it's 55 times 0.264 times 1. That's all in the numerator. And then we have 1 times 0.621 in the denominator. Okay, I'm just showing you again how to like deal with the fraction, because I know multiplying fractions, that's kind of crazy. If you're plugging this all into your calculator, I guess I would type it in more like this. The point being, make sure your numerator is in parentheses and then your whole denominator is in parentheses, because your calculator does PEMDAS, right? So by putting parentheses around your denominator, you're going to make sure you get the right answer. And then honestly, I wouldn't even write in the times 1 stuff. I'm just showing you like where they come from. So in my calculator, I would do 55 times 0.264 divided by 0.621. And you end up getting 23.38, 23.4. All right, and then here's the fun part. I promised you a fun part. Look, gallons, gallons, they're on opposite sides. They cancel out. What else cancels out? Ooh, miles, miles, they're on opposite sides, so they cancel out. What are we left with? In the numerator, there's a kilometer. In the denominator, there's a liter, and that's exactly what we wanted. Kilometers per liter. 23.4 kilometers for every liter of gasoline, or petrol, as they would say across the pond. Anyway, I hope that you can see how to do the process. I understand that it's quicker and easier to do it in your head if you can just like kind of see this in your head right off the bat. But be warned, sometimes you won't be able to do it in your head, or sometimes you'll make a silly mistake, and you won't know how to like check your work. It's like, well, I normally just kind of figure it out, but I don't really know if I'm doing it right this particular time. I wish there was a good process that I could use to make sure I'm doing it right for like more difficult problems. This process works, all right? It's tried and true. It's all about canceling out the units, and you're proving that you're getting a kilometer per liter. And by the way, we didn't really talk about this, but I guess we talk about it now. The fact that these two values are equal to each other. I'm like really throwing this in last minute. But let's look at this. We know that 1 liter is equal to 0.264 gallons, right? So they're equal in magnitude. This amount, if you had this amount gallons of gasoline in a jug, would be equal to the amount if you said, oh, I have 1 liter. The amounts themselves are equal. So that's good, because it's like saying, oh, I have 5 gasolines and 5 gasolines. It's the same amount. What happens when you do that division? What's 5 divided by 5? 1. All right, that's cool, Mr. Nangle, but like, why is that important? Because we don't want to change this value. We're not changing the magnitude of it. And we can multiply 55 miles per gallon times a magnitude of 1, and we still get the same amount. We're not changing the amount. If we were going to do 55 miles per gallon times 2, then we would change the amount. That's not what we want. We don't want to change the amount. We want to change the units. And that's what we're doing. It's all about changing the units. But this amount, the magnitude is the same as this amount. 55 miles per gallon is equal to 23.4 kilometers per liter. Because even though we're multiplying by stuff, the magnitude, the size of that stuff is equal to 1. So you're not changing the value, you're changing the units. And that's why this process works. So that's pretty cool. Anyway, that's about it. Thanks for watching and have a great day.